All righty. Okie dokie yogi. Ladies and gentlemen, so here is a man who needs no introduction.
That's as good as it gets. So have the presentation, please. Okay, I don't think am I on? I think I'm coming on. Okay, good.
So I do want to acknowledge Tom is on the board and he manages our inventory, the trailer, our materials, and does a jam up job. In a previous life, he was a IT manager, but came from an ag engineering background. You try to connect those two things.
That was easy. Yeah, I'll talk a little bit about it.
It's all yours.
Can I go to the presentation? And I think that's close enough. You're seeing this. Okay. Okay, this is going to be an introduction to this. I know some of you have been segmenting for a while, and when Roger asked me to do this, I said, you know, I've been a member of this club for 4 years, and I've never seen a segmented presentation out of this club. And I'd hate to hit the club with, you know, some of this stuff right off the bat. So I'm going to start at grassroots level here. Introduction. Okay, this is my agenda. A little bit about me. I'll give you some introduction on what segmenting is. And then I'll walk you through the steps of what it takes to do segmenting and some references at the end. So, bio, this is me. As Roger said, he didn't mention, I grew up on a farm in southern Kansas, born and raised. And after school, went to work for Caterpillar, worked for 36 years and retired about 10 years ago. The way it's tied together, IT and engineering, is when I started at Caterpillar, the systems that the engineers used to design the product were the responsibility of the engineering group. And I was an engineer, so I got involved in that. And over the course of my career, they moved that over into the IT department. Okay, so I was actually not an IT manager. I was something they called the chief strategist for the engineering systems, is all. It's enough about me. So, does anybody recognize this lathe? This picture was taken in 2019. Okay, that lathe is the old Sears Craftsman monotube. Yeah. So that lathe was brand new in about 1981. And I had that lathe until a little bit over 4 years ago. And this picture, that was my first open segmented turning that I'd ever done. And at the time, I was pretty proud of it. I look at it now and I think, oh, there's a lot wrong with it. But I joined the club shortly after I bought my new lathe. No, shortly before I bought my new lathe. You know, it's one of those things. Greatness is only one new tool away, right? Okay, I'll move on. So I've been a member of the club for a little bit over 4 years. Anyway, all right, segmented turning. Big field, a lot of different things going on in segmented turning. Basically, it's any kind of turning where you somehow join materials together either before or during your turning. Typically, it's wood that you're joining together, and it's typically glued together, okay? And I'm going to be talking about the typical stuff. A lot of different flavors, closed segment, open segment, bolt from a board, staves. You could keep on going. Okay. Just to give you some examples here, this is a gentleman by the name of Tom Voegeli. Some of you may have heard of him. He's had articles in Fine Woodworking. He's considered one of the real gurus in large segment count vessels. I think if you do the math on this one, there are 16,000 segments in this one. And I call it the wood turning version of pointillism, if you're familiar with the artist Seurat. Yeah. So if you make them small enough, Yeah. Anyway, this is one by Andy Chen. Andy is a master at really taking wood and maximizing the overall feel of it. The way he's got the feature ring and everything on here is really cool. This is a typical open segment. Again, a lot of segments on this one. And this is one that is interesting. Lately, there's been a lot of stepping outside the boundaries on segmented turning. This is a guy by the name of Paul May, who's getting into this weird, they're not horizontal rings anymore, which is pretty cool, right? Anyway, I'm not going to tell you how to make any of those. Okay, so my goals today, I want to try to get you through everything you need to know to make a segmented turning. And this, I hope this is more technique focused. I'm going to walk you through how to do this bowl, but the method you use to do it is applicable to any kind of a bowl, really an open segmented bowl. You'll run into some other things you have to do with multiple pieces that you then have to glue together, et cetera. But this is not bad. It's pretty simple. I want to get through it so you don't need a lot of math, and some of you are going, oh man, I came for the math. I know you are. Few jigs, as few jigs as you can. Minimal financial investment, and I wanted something that was fun to turn. So a couple of considerations here. I'm going to walk through how I do this, and there are a lot of different ways to do it. And they're not all right versus wrong, right? You probably have better ways to do it. That's okay. I'm just going to show you what I do. And I am under a lot of time constraints to try to show you everything you need to know about segmented turning in 75 minutes here. So some of this, like the actual turning, I'm going to talk to it, but I'm not actually going to show you on the lathe. All right. The target is we're going to go from boards. Boards? My pointer is not working. That's okay. We're going to go for boards. We're going to cut the boards into segments. Basically, take the boards, cut them up into little pieces, glue the pieces back together in the rings, glue the rings back together into a bowl blank, and then you're going to turn it. It's simple. Anybody can do it. So, first step before you get started is you have to, on segmented turning, you have to design the bowl blank. And you've got a lot of decisions to make. One is obviously the profile of the bowl that you're going to make. You also have to check or figure out what species of wood you're going to use and how you're going to combine those species together. Did I do that? All right. Any kind of pattern you're going to use. I kept it simple. I didn't try to mix a lot of different species in the same ring or anything like that. The ring heights are key. How tall you're going to make your rings and how many segments per ring. So you've got to make all those decisions going into the design. Interesting. Brad? What are you doing to me, Brad? Okay. All right. So the design is kind of, it's kind of boring, and I got to walk you through it. So the steps that you go through, you're going to sketch up a scale drawing of the bowl profile that you want. Then you're going to come in and you're going to add the height of each row, the ring, and the wood species that you want on those rings. Then you're going to measure the inside and the outside diameters on those. And then you're going to calculate the segment dimensions. There's a little bit of math there, just to warn you. You can avoid the math. I'll show you some ways to get around it. You basically let other people do it for you. All right, so you come up with a profile for the bowl, and you do it in graph paper, or you can use a CAD tool. The first couple I did, I used SketchUp. There's a free version of SketchUp out there. I think it's SketchUp 2017 or something. Anyway, you come up with this profile that you want of what you'd like to see. Then you add in your row heights and the species. So I happen to know that I wanted a bowl that was roughly 12 inches across at the top and about a third of that for the base, keeping with that, ratio out there that somebody was talking about. And then what you're going to do is you're going to measure the inside and outside diameters on each one of those rings. Okay? So for the base, it's pretty easy. What I did on this one is a solid ring. It's not actually glued together. And then you just basically start measuring the inside and outside diameters on those rings. And you want to give yourself a little bit extra there. I typically give myself 1/8 of an inch, both on the inside diameter and the outside diameter. And sometimes if you use software, et cetera, it'll take care of that for you. And you basically just go through those and you write them all down. So now you've got a table. It's basically what your rows are, what kind of wood you're using, how many segments per ring, and the height of the ring, and the inside and outside diameters. Piece of cake, right? That wasn't too bad. Now what you've got to do is you've got to come up with these dimensions for a cut list. If you're a flat worker, a cut list is something you take out of the shop, and it's what you cut your pieces to. So basically what we're doing is we're cutting segments. We have one here. Trapezoids. You know, little pieces like this. So you're taking perfectly good boards and you're cutting them up to little pieces like this, right? So each one of these that you see is going to be a trapezoid. So you've got to figure out how big to make that trapezoid so that you can, after it's turned, it covers up that entire portion of the segment or of the ring that it's going after. And there's a little bit of math here on how you do that. So, and some of you are seeing this and they're like, yeah, I need to get home and fire up Excel so I can key in these formulas and start doing them, right? And you can do that if you want. There are easier ways to do it. If you want, though, you can do all the calculations yourself, and then you just come in and you fill in those three things. What you're after is the miter angle, that segment edge length, which is how far it is across the outside edge, and then the board width. Those three things are what you need for your cut list. That's what you're going to use when you cut all your segments. So here's an example where I've gone through the math and filled all those in. If you don't like math, easy ways to do this. You can borrow somebody else's spreadsheet that's already got the equations in it. That's easy. You can go to the web, and if you search for segmented ring calculator, you'll find all kinds of things out there where they will ask for three things. They'll ask for the number of segments per ring, the inside diameter, and the outside diameter. And they will give you three things back. They'll give you that board width, the segment edge length, and your miter angle. Okay? And most of them are free. So, yeah.
You said your rings have 16 segments, but your drawing up there shows 8.
Yeah, because when I tried doing it with 16 segments, I couldn't squeeze it in very well. So this was an 8 segment example. Yeah, it was just harder to see. So yeah, good catch though. Okay. Another way to do it is you can use AI. If any of you have used Gemini or ChatGPT, I can guarantee you that if you put in a question to them that says, hey, what miter, SEL, segment edge length, and board width should I use for a 16 segment ring with a 5-inch OD and 3-inch ID, it's going to give you a page. It's going to tell you what the answers are, and it's going to give you a page of how it came up with those. And you do that 5 times for your 5 rings, and you're done. You got your table filled in. And the other thing you can use is there is specialized software out there. The one I use for a lot is Woodturner Pro, and I think it's like $80 now. You do a few of these by hand, and after you've done 3 or 4, if you like doing it, you find that spending the $70 or $80 for the software is a pretty good deal. And there are other software pieces out there, but not familiar with them.
Is your spreadsheet gonna, is your PowerPoint gonna be on our newsletter?
Yeah, I don't have a problem putting it on the website. Brad? Yeah, okay. And if somebody wants a spreadsheet, I can send me an email and I can send you a spreadsheet too. Okay, yeah. All right, and I originally was going to do a little bit of a demo on Woodturner Pro to show you how easy it is. Literally in just a couple of minutes, you can lay out your profile, you lay out your ring heights and segment count, and it spits out a cut list for you. You know, it only takes a few minutes. All right. So the final step here is you go through this and you simplify that board width. If I go back to this picture, that board width there, if the board width is a little bit bigger than it needs to be, that just means you're going to cut away a little bit more material with your lathe on the inside of the bowl. So the board width can be bigger, not smaller, but it can be bigger. So back on this spreadsheet, you see on the board width, that column there, inch and 5/8, inch and 9/16, inch and 9/16. Those are only a 1/16 of an inch difference. So I am not going to rip separate boards that are only a 1/16 of an inch different. Instead, what I'm going to do is I'm going to make those three all inch and 5/8. And likewise, the top row and the second row, row number 2, I'm just going to make both of those inch and 1/4. Simplify things. So I'm not ripping separate, you know, a lot of different lumber. Okay, and there you go. That's your cut list. That's what you're going to take out to the shop and you're going to use to cut all your segments with. And I'll show you how you cut your segments. All right. Hopefully that was the most boring part of the presentation, but I'm sure you'll let me know. Now we're going to move on to cutting the segments. And you want to start with straight flat boards. I usually take, you know, good solid lumber and I run them through a planer and or a drum sander to get them nice and flat. And you want to try to make sure that they're a nice consistent thickness, because if they're not, you'll just have a little bit more work flattening things later on. And before you start cutting the segments, you want to cut all the boards to width, back to that board width on the chart. All right. Now we're going to move on to actually cutting the segments. And we've got the board width down. Now the two dimensions that we're still dealing with are the miter angle and the segment edge length. And there are a lot of ways you can do this. People used to use miter saw was the tool of choice. And then back in 2018, I believe it was, a guy by the name of Jerry Bennett came up with this thing called the wedgie sled. And rather than asking, you know, patenting it and asking for lots of money, he turned it loose free to everybody and even published plans on how you can make your own wedgie sled. And I think most people today use a wedgie sled. I still see some people every once in a while that use a miter saw, but it's pretty rare. And you'll see the advantages to it. This is a wedgie sled. This is where we might need the camera here, Charlie. Hopefully you can see this. So the heart of this is the sled itself. It's just got a miter track here to run on your table saw. It slides in the miter slot. And then this is basically just two arms, fences, that freely rotate, and you can lock them down. That's all it is to it. The other piece that I have here is a stop. This goes in the other miter slot and slides back and forth, and it lets you basically put a stop for the length that you want. And this is nothing more than it's got magnets on it that I put on my table saw. It serves two purposes. One is it's a zero clearance board, so it goes right up against the blade. And then it also has this ramp on here so that when your segments are cut, they slide down. Instead of going into the saw blade, they slide away from the blade. Okay? So the way you use this is you take something called, Jerry Bennett called them wedgies. I just call them wedges. You get one here that's, I don't know if you can read it. It says 16 segments or 22.5 degrees. And This is the angle. It's cut to 22.5 degrees with this angle. You take this guy, lock it in, move it down, and now you've got two fences, these two fences, that are 22.5 degrees apart. And it's fast, it's easily repeatable, and it's accurate too. So you can go in a matter of seconds, you can go from 16 segments to 24 segments and back again really easily. So that takes care of your miter. The beautiful thing about this one is it doesn't matter whether it's slightly off, the middle isn't on the line. What's important is that this fence, this top here, and this here are 22.5 degrees apart. And that's what your triangle does for you. It doesn't matter if it's crooked. As long as this wedge is in there tight, these two are going to be 22.5 degrees apart. I can move this guy way down here, as far as it'll go. And it's still 22.5 degrees apart. Yeah, that's the beautiful part about this one, is it just locks it in at that 22.5 degrees. Okay, so like I said, Jerry has plans out there on how to make this one. And there are a couple of different varieties. This is one that uses the cuts with a router to make, but it's a piece of cake. So I don't know, Charlie, if you can get this on the camera. But what you do is you take your board that you're going to cut, and you set this distance on your stop to that segment edge length. This distance from here to here is the segment edge length that we calculated. Okay? And once you have that dialed in, you lock this down so it doesn't move. And that's the distance that you're going to cut. I'm going to move this one in a little bit. Actually, what it's going to be, something more like that, right? Okay, and then to use it, you basically just run this one up to the blade. Blade on the table saw would be right here. Run it up and you cut this segment off. Then you move your board up to there, top of the fence. You do the same thing. And you run that and to cut this next one. So you basically just go back and forth with your top and bottom. And you got wedges. And you do that, you make 16 cuts 5 times, 1 for each ring that we're doing, and you're done with cutting your segments. Piece of cake. What did I do? All right, let's go back to the presentation if we can. Okay, the last step in cutting the segments is you want to look at your segments and check to make sure that you don't have, yeah, go ahead.
I'm missing something, how you get the wedge shape.
Ah, it's this angle on these two fences.
Oh.
Yeah, so if I cut this one, the table saw blade will be right here. If I run that up, it's going to cut at an angle, and when I move it up here for the next cut, it's going to cut on this line. Sorry? 22. Yeah, 22.5 degrees. As long as you can get, yeah. It's 22.5 degrees apart, yeah. The length is with this stop. So I take a ruler. I go back to like this chart. I think it said one of my segment edge lengths is 2 inches. So are we back on the camera here? Okay. So this is the stop that's going in the other miter track. This sled will go in one miter track. This one goes in the other miter track. When it's locked into the miter track, what I'm going to do is I'm going to measure, if I went 2 inches, I'm going to measure 2 inches over.
Want me to hold one up so you can kind of show it?
I don't know, can you see that? So if I want 2 inches, I'm going to measure over 2 inches, and then I'm going to lock down my stop block. And that will give me 2 inches on all of those cuts. And I would say one of the things that you want to do, it's difficult to do this if you don't use a wedgie sled. The miters, if you use a normal binder gauge on a table saw, you'll spend a lot of time locking in that 22.5-degree angle and getting it accurate. This is the one jig that I think if you're going to get into segmenting, you probably want to invest the time into. And like I said, the plans are free. Jerry's website, segeasy.com, he has instructional videos. I'll give you references at the end. He's got instructional videos on how to make it and also how to use it. And it's worth the time to, if you want to try this, to look at those videos. They're pretty good. Okay. All right. So you're going to check all these segments for rejects. And this over here, I think this was a sample that I was cutting for big leaf maple. Well, a lot of defects in the segments that I throw those away and cut replacements for. And the other thing you want to do is when I come off the table saw, they've got little burrs and stuff on them that you want to, what I usually do is I take a sanding board. Sanding board is just a 8.5 by 11 sheet of MDF or whatever, has a piece of sandpaper glued on it. And I just run the segments on it to get the burrs off, okay? Because the burrs, if they get in your glue joint, they're gonna hold it apart. You're not gonna get an accurate angle. All right? So you got your segments cut, piece of cake. Again, do it for 5 rings and you're done. 16 segments times 5, it's all good. Then you wanna glue those segments into rings. So first thing you probably want to do is dry fit and check for gaps. And I'm going to show you this. It's funny. The same wedge on the sled sometimes will give you dead accurate miters, and you'll do a 24 or 30 segment glue up without any gaps on the miters, and it's golden. And the very next day, with no changes, you might do a cut and you'll get slight gaps in the rings. So I'm going to show you what to do in both situations. So I have 16 segments here. Yeah. And sometimes it changes during the day too with the humidity, believe it or not. So the people that are able to do this repeat it just, without having to do anything, they always get dead accurate miters, just amaze me. Okay, that's a dry fit. Okay, piece of cake, right? Do that 5 times, glue it together. 5 times, you're done with gluing up the rings. Okay, this one looks pretty good. If you hold it up to the light, you see no gaps. Okay, so I'll cover that next. Yeah. I am going to show you first the actual glue up process. Yeah. So what I normally do is stand all these up. So the glue I normally use, I get asked this question a lot. The glue I normally use is for gluing up rings, solid rings like this. I use this Tight Bond 3 just because it's got a nice long open time, right? Okay. The thing you have to be careful of is if you're not careful, the glue will start to set up before you get done with the glue up. So what I usually do is I just go through and do a bunch at a time. And don't go too thin on the glue. You're gluing up end grain. So it sucks into those straws really quickly. So pretty exciting, huh? All right. And then you basically just go around. Now that I know that my miters are good, and then you can just take your rubber band again.
The trick with the hand, that's only right.
Okay. And you want to make sure that obviously they're aligned, that the insides are good. The other thing that you want to make sure that you're doing is they're flat. They're down all the way. And that just saves you a lot of time later on. I'll show you that I'll usually go through and re-flatten these anyway. But it's a lot easier if they're almost flat to begin with than if they're way out of flatness. And then you just wipe them off. Should probably throw a... It actually is. I hardly ever use anything else. There are people that will use hose clamps. I don't see the advantage to it. Actually, Rick, where's Rick? Rick and I were fortunate enough to hear a guy from Tight Bond to give a presentation to the flat workers group a couple of years ago. Remember that, Rick? And he said that the strongest glue you can get out of Tight Bond is when there's actually not very much pressure at all on the glue. Yeah. Yeah, what you do get, if you put a lot of pressure on it, is you will get thinner joints, but they won't be as strong. So you'll get thinner glue lines. So I find that if I put 3 rubber bands on, that's usually enough. And there you have a ring. And if you let this sit for, an hour or so, then you can flatten it and move on. And you do that 5 times and you're done with this project that I've got. Piece of cake, right? Yeah, it's easy. Okay. Yeah. This rag is wet. Yes. I'm just wiping the glue off the faces just to make it easier to flatten later. Yeah.
Tom, I have a question. Do you ever put a piece between the angled segments that's not angled?
I have, yes. My very first non-open segmented turning I did was that. Yeah. Where you can basically take this, and if you just have a flat little strip of wood, you can lay it between these. Your ring becomes larger, but the miter on these segments doesn't change at all. It just gives you a slightly bigger ring. Yeah, yeah, easy to do. Just straight, no angles at all. Yeah. Yeah, one in each joint. In every joint, yeah.
The grain direction is doing?
Yeah, it doesn't really, the grain direction. So the purist would tell you that what you want to avoid with segmenting is showing end grain on your segments. And when you look at it from the end, you don't see edge grain, right? So normally, if you put the piece of wood between them, you cut it so the edge grain is up and down. You know, you'd see the end grain up top and at the bottom, rather than on the sides. Yeah, that's from a purist standpoint. Yeah.
I'm just thinking you could really get creative and use veneer and.
I'm going to talk about veneer.
Oh, sorry.
Yeah, no, that's okay. Good lead in, man. Okay, so by the end of tonight, this one will be pretty much set up, and I won't have to worry about it. Hose clamps, if you want to use them. There's a hose clamp that people would use. What you have to watch out for with a hose clamp is this thing right here. A lot of times they have a little thing that sticks down that will distort your ring when you tighten it up. But like I said, I hardly ever use it. The only time I use one of these is when I have a really difficult glue up and I can't really get a rubber band on it very well. But yeah. Okay.
And is this just a piece of mica or?
Yeah. I should talk about that, shouldn't I? So I debated what I should bring to this presentation because I didn't want to get glue all over these tables at the school. So I went to, my son owns a cabinet shop, and he had some of this scrap material left over from a set of kitchen cabinets that he had made for a customer. And it's an MDF with basically a melamine kind of finish on both sides. So I said, that works pretty well. And not only that, I can wipe it off, don't have to worry about it soaking in. What you want is a nice flat surface to do the rings, right? If you're not gluing up on a flat surface, then your rings aren't going to be flat. So this is pretty flat, and it doesn't distort very easily.
What's your son's address?
Bellingham. Yeah. Okay. So that's if your miters are good. If you're fortunate, I've got to say, maybe 75% of the time I get good miters. About 25% of the time I don't get good miters, and I have to resort to the next thing on the list, which is what they call a half ring method. And what they'll do, what I will do, more segments. Charlie, got the camera again? Okay, if you probably can't see it from there, but I definitely have little gaps. You can see the light through the gaps on this one. So what you do is, instead of gluing up the whole ring like we did with this one, you're only going to glue up two halves. So I'm going to not put glue on that joint and this joint. Yeah, give me my pin. And you stick a pin in between these two. These are just shelf pins that I bought at, I think I got them at Lowe's, Home Depot. You can use nails. Anything that's round works pretty well. A small dowel works pretty well. What happens when you put those pins in between is it forces all the gaps out of these two half rings, and it moves all the gap into where the pins are. Okay? So when you're done with that, you glue it up with the pins in place, yes. And when you're done with that, then you have two half rings that look like this. Okay, and they don't line up very well. They have a gap between them, right, where the pins were. Okay, so the half ring method is you take the edge on all of these, and you put some pencil marks on them. And you also mark the top. Put an X on what's the top on both of these. And then you flatten them. There are two ways to flatten these. What you're going to do is you're going to flatten these. Since these are half rings, you want this to be perfectly straight, right? There are a couple of ways you can do this. One is if you have a disc sander, you can lightly hit this with the disc sander and flatten both faces at the same time. And then it'll be a good, straight across, right? If you don't have a disc sander, you go to something like this. This is just a 4x4 sheet of wood. I think it might actually be a couple of 2x4s. And it's cut to where it's pretty close to being, square. It's not quite exact, and it doesn't have to be, and I'll show you why. You put that on a piece of sandpaper, then you take one of your half rings, and you hold the X, which is the top, next to the board, and you just run it back and forth. And you sand it down to where you can't see the pencil marks anymore. And I don't know if you guys want to see me do this all the way. Okay? That's pretty close. For the other one, you do it that's got the X that was at the top. You do that so it's not against the board. And you do the same thing. And the reason you do one against the board and one that's not against the board is if this thing is not quite 90 degrees, not quite square, if I did both of the X's against the board, when I put them together, they would be like this. But since one is the other way, when you put them together and glue them together, then you won't get that. It'll be straight across. Okay? You do. Do it with a disc sander too. Anytime you're uncertain on your perpendicularity, definitely. Yeah. Then you glue it up, just put glue on it and put rubber bands around it and let it dry. And you've got your half rings glued up. And again, you do that 4 or 5 times and you're done with the ring glue up. That's it. So again, pretty cheap. I usually don't use a block. What I will use is the fence on my table saw instead. I'll slide a piece of, if I'm not using the disc sander anyway. I have a disc sander, so I use the disc sander. But some of these rings, like the 12-inch rings, the outer ring on this that I'm showing you tonight, it's too big for that because I've only got a 12-inch disc. So on that, then I'll resort to this kind of a method to flatten it. Yeah?
Do you find that using a disc sander is too aggressive and you end up taking off too much?
I try to be very gentle. You don't want to take off too much. Sometimes you can get away with taking off a little bit more than you should. But you don't want to because then your circles aren't circles.
Like that would be a safe move.
Yeah, definitely if you're using a disc sander, you want to practice a few times. A light touch is all you need. And you can normally feel and see when you're pretty close. I normally run with a pretty fine grit on my disc sander, so I don't usually have that problem. I haven't had that problem lately. Yes, you do. And that's if your rings are larger than that radius of your sander, then you've got to resort to something like this block and your sandpaper. Okay? Let's see. Back to the presentation, if we can. All right. So, half ring method. Let's see. Did I talk about all this? Yep. I think I'm good. Okay. Large rings. So I talked a little bit about this. Some of these rings are too big. You saw the trick I did with the hand. If you've got nice long fingers, you can get them on that ring and put the rubber bands around them. It won't work on your larger rings. These guys, they're a little bit too big for me. So what you can do is you can ask a friend for help. and you can just use rubber bands. Normally 4 hands work pretty well. You can usually get the rubber bands around those segments. What I will do is typically one of these latter 2 times, just because Jennifer, my wife, I don't want to have her get glue all over her hands. So I'm going to go through both of these. This is one where you've got a large ring, and what I'm going to do is what's called a rub joint. And this is interesting because you don't use rubber bands. Back to the previous discussion on, do I need to clamp them? This here, I should wet this off. This is where I would probably go to a different glue. This is Tide Bond Quick and Thick. They claim that it dries twice as fast. I don't need a long open time on this one, on a rub joint. As a matter of fact, I don't want an open, I want it to dry as fast as it can. So a rub joint is really simple. You just take one segment and you put glue on it. Take another segment, you set them down and you rub them together on that joint. Can you see that? Okay. And you'll start to feel the glue grabbing after a bit. And when it starts to grab, you stop, wipe off the excess, straighten it out, make sure it's flat, and set it aside. That's all you need to do. You don't need to put a rubber band or anything on it. And what you will do on this guy, rub joints for a large ring, is you would do pairs, glue together the 16 rings into 8 pairs, and then you would glue together the pairs into pairs of pairs, and then glue those together into half rings. And now you've got a half ring, and now we know what to do with a half ring, right? Back to the presentation. Glue up the pairs. You got 2 half rings. You check those half rings to see if you've got a gap. If you've got a gap, then you go to sanding them like I showed you. There's using my fence on my table saw. And then you've got your completed ring. And you're good. Okay. So you know how to handle that. So the thinner I ever go on a ring is about 3/8 of an inch. If it's smaller than 3/8 of an inch, then I won't use a ring glue up method. I'll use some kind of an indexing jig to get it glued up instead. And I will show you a little bit about indexing jigs later, because it can be very difficult to try to keep it flat, right? And I'll talk to that in a little bit. Am I doing on time? Good. Okay, the other thing you can do on large rings, something called a pin board, which is real simple. I've just got rings of holes on here, and what I'm going to do here is I'm going to take my pins Some people just use nails and just beat them in. There's nothing fancy about the spacing, anything else. These are just to hold the rubber bands. This is what you do if you don't have somebody else's hands and you don't want to go through that whole thing of
Smart.
Yeah, it works pretty well. This is what I would normally use. And I've got some segments here. Large ring segments. might have gone too small. I did. Let's go one bigger. Okay, now we can do this. This one, I would definitely recommend practicing on this before you actually put the glue on the segments to get a handle for what it feels like when you're doing it. Sometimes the pieces will just fly everywhere.
Put a small hole in the center.
Yeah.
Smaller, slightly smaller hole in the center, upside down. No?
I'm sorry?
What if you put a smaller hole in that diameter in the center, upside down, in case it presses?
You probably could do that. Yeah. 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 Okay. And then I could have gone smaller. All right. So you basically just start working your way around, either pulling the pins out or just popping the rubber bands off. And if you're careful, the segments really don't have anywhere to go. They will stay together.
If you had one of your smaller segmented rings that would fit inside, it would also have that segmented section.
Yeah, you just have to be careful that it's smaller, a little bit smaller. Okay, and then you can go through and make sure they're flat and all the things are, the points are lined up. And that's a pin board. Like I said, a lot of people just use nails. And they'll just take a scrap piece of plywood and they'll pound nails around the outside. Okay, so those are 3 ways that you can handle large rings. Now let's talk about veneer. So there are at least 3 different types of veneer that are out there. There's solid wood, that's the best you can use. It's also pretty expensive, it can be hard to find. You might have to, if you've got the equipment, you might end up having to make your own. I don't usually, unless I can find it somewhere, I don't usually have a lot of that on hand. It can, like I said, can be expensive. Paper-backed, which is what I have here. It's got paper on the back of it. You can use this, and I have on all of these that I've got up here. The thing to be aware of is the experts out there will tell you not to use this because what you will have on the completed bowl is, if you feel it, you'll have a little bit of a dip or a bump where that paper is, because the paper gets eaten away a lot faster when you're sanding it, right? Or it sucks up the finish in a different way, etc. So if I was going into a gallery, I'd probably want to use real veneer instead of paperback, but I'm cheap too, so. Let's see, the third one is there's something called woodback veneer, and I've never worked with it. I think this is relatively new. It's got the veneer, if the grain of the veneer is vertical, they'll put a horizontal wood backing on it. I've seen it before, I've never actually used it. And that's supposed to eliminate those bumps. It might still give you a little bit of a different color where that wood is, the wood backing on it, because they typically use a different, I don't know, has anybody tried working with wood veneer?
I've never heard of it.
Okay. Okay, in most cases, what you want to do is you want to glue on the veneer onto the boards before you cut them. So this is just a piece of wood and I've glued on this paperback veneer. I'll clamp it, let it sit, dry overnight before I cut them into segments, right? Not too difficult. On small stuff, this is an example. The base of this bowl that I'm making here tonight, it's pretty small. I won't go through the effort of gluing on veneer and then cutting the segments. I'll just take a piece of, veneer and glue it on. The purists out there will tell you not to do that because the end grain shows. Yes. Okay. And it does. Sometimes you have to look really hard to see the end grain. Yeah. And usually this thin stuff, it's pretty hard to see where the end grain is on your vinegar. So what I'm doing tonight is I'm not bothering gluing it on. If you do glue it on, you have to make sure that when you cut your segments and you glue them up, that it's really flat, because you can't come back later and flatten off that veneer. You'll burn through it, right? So anytime you're working with veneer, you just need to make sure that it's really flat when you glue it up. You can lightly sand the joints, because usually the water in the PVA glue will cause the joints to pop up just a little bit. You'll get end grain and stuff rise up a little bit, and you can knock those down with like a sanding block, but you can't do much more than that. So you just have to be really careful. This lower picture here is an example of a bowl that was glued up and it wasn't flat. And when you turn it, it's very visible that it wasn't flat, right? You can see how the jagged edges where the veneer is on that. So again, learning from experience. Let's see. I think that was it on the veneer. That answer your question, Roger?
Yeah. If you need veneer, come talk to me. I have a stack in my garage I'd love to get rid of. I also picked up some veneer. It's probably maple, but it's dyed black.
Yeah.
Which sounds like, that sounds like something you could really be creative with.
Yeah, that's probably uses the old vinegar and iron trick.
Oh.
Yeah, if you take maple and you put it in a solution of iron shavings and vinegar, yeah, it has a chemical reaction with the tannins and it will turn the wood black. And it's a poor man's ebony.
Okay.
A lot of people will do that, yeah. Steel wool, yeah, there you go. Okay, gluing, so we're good with gluing up the rings. Now we're just going to glue the rings together. And this is not very difficult. I just lost my piece, didn't I? What did I do with it? Here. Okay, so what I did here, this is just a waste block. I put a faceplate ring onto a waste block, and then I glued that 4-inch base that I had measured out. I glued that on there and I let it dry, and then I just turned it around. That's it. And it's bigger than it needs to be, about 1/8 of an inch, 1/4 of an inch or something. And I'm just going to take a piece of veneer and glue it on. And this is probably an instance where the end grain showing on the veneer doesn't matter, because you're going to be showing end grain on the base because it's a solid piece of wood on the base. So you're going to glue that on. Then you're going to take your first ring and you're going to glue that on. And I skipped a step. Before you glue these on, this is where I should go back to my presentation. The first thing you want to do is flatten one side of your rings and make sure that they are dead flat. If they're not dead flat, you'll get gaps between the rings, and you don't want the gaps. Not only doesn't it look good, but it can be exciting to turn. So 3 ways to do it. One is for small rings like this that's thin, 3/8 of an inch. Again, I'll just take a sanding board. This one's 80 grit, and just run it back and forth a few times, and you'll see when it's nice and flat. And I've done that on this one. On the other rings, a method I use a lot is I will mount the ring into a coal jaw setup, and then I'll use the sanding board. And you got to be careful on this. Make sure you have a good, nice, tight grip on your sanding board. You mount it in your coal jaws, you turn it on low speed. I wouldn't go any more than a couple hundred RPM if you can. And then you hold the sanding board up to it with a good grip on it, with nice even pressure on the center of the board so that you don't get a cupping happening. And after a few seconds, your ring will be nice and flat, right? And you want to do that for, like I said, all the rings. One side is what you need. If you've got a drum sander, that's even better. You can run the rings through the drum sander, and you can actually do both sides on the drum sander because you know that it's going to be nice and even thickness all the way across. I usually use the middle method here on the larger rings. On the smaller ones, like I said, I use the sanding board. Okay, so you have to start with that. And now you're going to glue them on. Back to my rings. I will show you. When I'm using the coal jaws, what I don't want to happen is that one side will be dead flat, and the other one will be dead flat, but it will be angled a little bit, right? Well, my experience with the coal jaws is it can be difficult when the coal jaws, when you don't have pressure against the coal jaws, that the ring won't be fully flat the way you want it against the inside of the coal jaws, right? And if you can figure out a way to do that, unless the side that you're putting against the inside of the coal jaws is flat already, then you're okay, but that's not the case. So I will only do one side and I'll get that flat, and then I will wait until after the ring is glued onto the blank before I flatten the other side, and I'll talk about that. So back to this little guy, what I will do is I'll take the sanded side and I'll glue it on. And this one is easy. I don't have to worry about the bricklaying pattern, getting that oriented right. But what I do have to worry about is making sure that it's centered, that it's not like way off to the side, right? And there aren't a lot of ways to do that other than on a ring this size anyway, where it's this thin. My buttons on my coal jaws won't let me get this guy in. So what I will end up doing is just using a ruler or by eye. I will lay it on there and I'll go around on the outside and just make sure that I've got an even distance all the way around to make sure that it's centered. Okay. Then I'll put on another piece of veneer on that. And then I'll go on to my next ring. And to simplify this, I'm just going to show you what happens here. On this ring, what I want to do is I want to make sure that it's in a good bricklaying pattern. So I want to make sure that the points on the first ring line up in the middle of the lower segments, right? And if you're good, you can kind of do it by eye, right? And you'll get pretty close. Or you can use a ruler, and that will get you pretty close as well. What I will usually do is I'll just reverse chuck it in my coal jaws and then move it in and put glue on it, right? And move the coal jaws in, use the lathe tailstock to apply the pressure on it. And that makes sure that I got it nice and centered. Make sense? Okay. And you can get by with it. Your rings will look a little bit different. One side might be a little bit fatter than the other because it's shifted a little bit. The other thing you have to make sure is you've got enough material to where, that 1/8 of an inch leeway that you gave yourself, that you have to make sure that you're within that 1/8 of an inch or your diameter is going to turn out different. Okay. But other than that, it's you do that 5 times, and you're done with this bowl. You've got a bowl blank, and it looks like this. And now you're, after a day of gluing stuff and waiting for the glue to dry, you're finally ready to turn. Okay. Other glue-up methods that are out there. One that I want to show you is this one called a Seghese plate. Basically, it's a plate that has these grooves in it so that you can slide in 8 of your segments. You put a rubber band on it. Go ahead and do that just to hold them into place. Okay, you reverse chuck this onto your lathe. You put glue on it. Back to the presentation. And you use your tailstock to apply pressure, and you let it sit. And what you end up with is something that will look like this, where you have 8 segments. And you're missing 8. So then all you do is you take the remaining 8 segments, you put glue on them, and you slide them in. Okay, the nice thing about this method, a lot of people don't use this method, by the way, but it is interesting in a couple of aspects. It's pretty easy to use. It's really forgiving on those miters. What it doesn't allow, if your miters are off a little bit, it doesn't let that air in the miters accumulate. It keeps if you're off by like 1/10 of a degree on one segment, it makes sure that that 1/10 of a degree is isolated to that one slot that it's in. It doesn't let 16 times of that build up so that you have a gap at the end, right? Unfortunately, these things aren't the cheapest. I think this is like $50. But where this does really become interesting is when you want to get into open segmented turning.
You were really impressed for a minute there. Now
Yeah, no, I have to tell you, I wasn't able to use a jig on these. On an open segment, it looks something like this. This is called a 24/4 ring, meaning that it's 24 segments with a 4-degree gap between them. Yeah, so it does the spacing for you. You don't have to go through and do all that spacing yourself. And people that get into open segmented turning, this is usually where they start. They get one of these plates. And you just have to make sure that when you cut the segments, rather than going the full miter angle that you would normally go, you make it 4 degrees less so that you have the 4-degree smaller segments to go in these, right? And then you do the same thing. You put this in a reverse chuck, and you use your tailstock to apply pressure. All right. The last thing on these. What happened? Index jig. Okay. This one is not too difficult. These can be expensive. These run in the $300 to $900, depending on what you want to do. So the key here is you have this index ring at the back that has all these holes in it that you can dial in degrees of rotation. And then you have a stop on this little table that lets you put the segments at the right diameter that you want. So what you do is you glue in a segment, you spin the rotation, the amount of rotation you want, then you glue in another segment. So you do one segment at a time. Those pictures of Tom Lohman's piece where he did 16,000 segments, that's how he does it with an indexing jig. And what he will do is he will not glue in one segment and then go to the next segment. what he will do is he will glue in one segment and then jump down, skip 5 or 4 segments, and then glue in another one. He'll let all that dry, and then he'll come in later and glue in the 4 or 5 in between manually. So, piece of cake. It does. So normally this stuff, in a half hour, after setting for a half hour, you can usually work with the pieces. I wouldn't turn it, but you can usually glue in other segments without too much of a worry. Yeah. I give myself, like I said, usually about a half hour between the rings. Within a ring. Yeah, I would still give myself a half hour. Between the 4 or 5. I'd glue down I'd skip the first row that just had the segment and skip 4, the segment. I would let that dry a half hour before I slotted the other ones in, just so it's tight. Otherwise, it can be, like I said, interesting.
Tom, I'm trying to figure out how you can do all this gluing up without driving yourself crazy. I don't think, what do you got, dental floss that you put in the hole and what?
Yeah, and I didn't want to talk about open segmented turning, but yes, on an open segmented turning on these, getting rid of the glue squeeze out is something that you have to be prepared to do. You glue on a ring or a row or even a segment at a time, and then you come in. I use a flat dental scraper to scrape off the glue, and then I come back with a pipe cleaner that's wet, and I wipe it all down and get the excess glue off. Yeah. Yeah, so it can take a little bit of time. But that's what you have to do with open segments. Yeah, I've never had a problem with getting enough squeeze out. Yeah, it's pretty, so with the quick and thick what I will do is usually hold those joints together for like 10 seconds. And after 10 seconds, it seems like it's not gonna squeeze out any more than it would. Yeah, with just a little bit of pressure. Okay. The nice thing about these jigs is you're not limited to having the same size segments all the way in a ring. They can be mixed. This is a good example where some of these are a lot smaller segments than the others. Some are fatter. You can't do that with any kind of a jig that you can buy. This is another example of the same thing. And this will let you do both open and closed. And you can do actually 192, but you can actually do a lot more than that if you do that skip method that I was talking about. Okay. Finally, turning and finishing. I'm running a little bit late here, not too bad. First point here is you want to use your PPE, right? How would I know? Okay, so the first one up here on the upper left, that's actually this guy. Yeah, I was on the final standing with 240 grit. The opening was a little bit too small to where I could get my hands in there comfortably. I was using an inertia sander. People probably know what that is. And it caught and came loose and blew right through the bowl. Okay. Yeah, so you can get some exciting moments. To be fair, I've never had a failure like this on a closed segment bowl. Usually there's enough glue surface on a closed segment bowl, unless you've turned it too thin or you've got a really bad design. You shouldn't have a problem with it blowing out. Open segments are a little bit different. So I was telling Ray that when they have the estate sale at my place, they're going to find segments laying all over in my shop. Yeah. Okay, turning and finishing is a lot like any other turning and finishing. A couple of things that you have to watch out for. When you first start turning it, you want to make sure that your tools are really sharp, and you want to take really light cuts. And you want to start by going after the corners first. If you want to be too aggressive, the way this is glued up, the interesting, am I dead? Did I go out? Okay. Is you'll probably get a chance to turn grain direction like this. If you look at this, you're turning with the grain. It's like your lathe is running up and down the tree instead of in grain or cross grain, right? But if you're not careful and you try to be too aggressive with your gouge when you start turning this, on the points, it will have a tendency to catch and tear off big pieces. And you don't want to do that. So when you're first starting out, just go real light, really sharp tools. Once you get the points off, it usually turns down really well. And then basically after you turn the outside and the inside like this, then you can just part it off and put it in coal jaws or jam chuck to finish the bottom. So, and finish of choice, Danish oil, etc.
And Tom?
Yeah.
Way in back here.
Yeah.
Are you cutting like you would a regular bowl from smallest diameter to larger diameter?
I go the other way. So I start on the outside and work my way in.
Okay.
Because if you start here, I've had bad things happen.
Okay.
Back, this lower one here on the lower left, that was one where I tried an upcut on it, and it didn't like that at all. Yeah, blew out. Yeah, go ahead, Tom.
Okay, when you're using dissimilar woods, you have to pick out the ones that play well together. Like, you know, whether it's like say a domestic and an exotic.
I haven't had a problem. This one is cherry and wenge, and I really, people say, well, it's the wood's going to sand at different depths, etc. I really haven't experienced a problem with mixing, you know, different woods. I'll use soft maple and wenge, or you know, a hardwood.
How about oil content? Is that an issue?
It can be an issue with the glue up. You have to make sure that your glue works well with an oily wood.
All right, thank you.
Yeah, I don't work a lot with really oily woods. I mean, wenge or, you know, mahogany or something. That's about as exotic as I get. And you end up with a bowl that looks like this, and you're done, and it was a piece of cake, right? 5 rings. Math wasn't hard. You do a little bit of sanding, flattening, etc., but it's pretty good. So, last part here, references. I told you I would show this. There is a chapter of the AAW out there. It's what I would call a remote chapter. All the members are spread all over the world, basically. It does cost $25 for an annual membership. Has over 500 members. If you have any questions about segmented, you just want to get inspired about segmenting, etc., you go to that and you'll get all kinds of answers. One of the best things you can do to grow is publish a picture of one of your works on that website, and you'll get lots of critiques. Yeah, some that are really valuable and some you wish you'd never seen. There are a couple of articles out there, Fine Woodworking, American Woodturner, on beginning woodturning, or beginning segmenting. Those are good. A couple of books. The one, it was written before the Segeezy, the wedgie sled came out, but he goes through a lot of detail about segmenting. This is Malcolm Tibbetts. He's one of the fathers of segmenting, if you will. It's an excellent book. There's another one here, which I've read by Dennis Keeling on open segmenting. It's pretty good too. There are other books out there that are good. Those are just the two that I'm familiar with. They're how I got started. And then the websites that I've mentioned. Jerry Bennett, the Segeezy Solutions, that's his wedgie sled and the wedgies, and the instructional videos. Lloyd Johnson has software out there. There are other pieces of software you can use for segmenting. And Chefware Kits is one of the companies that does an indexing jig that you can look at. Okay. I think that's it. Yes.
The piece that's
That blew
over
up?
there that blew up.
Yeah.
How did you put it back together?
CA glue and a lot of cursing. Yeah, and interestingly enough, if you look at it, you will notice that there is one glue joint here which is abnormally fat. When I glued it back together, I was unable to get it closed all the way, so that's why. And at the time, I was debating whether I should just burn it or not, and I didn't. So.
All the king's horses, all the king's men, right?
Could you put the reference slide back up, please? What it is? Never mind.
It'll be on the website. We'll post it. See that handsome fella back there with the computer?
Yeah, I'll
He's
I'll
gonna
make
handle
sure
it.
that this is out there on the website. We'll get it out there.
We got a couple minutes for questions. So here's a plug for why you need to stay in a club. Jerry Bennett and Andy
Chen?
Chin were both members of the Houston Club when
Yeah.
I was there.
Yeah. And
Till
I think they are
2004.
both presenting down at SWAT
Yeah.
this year.
They're really talented guys.
Yeah.
We had one guy here like that. He left. Don't tell George I said that.
I
hear that?
I probably did 4 on my Craftsman lathe. And at the time I said, there's a lot going on here that I don't know how to use a lathe. I need to back up and learn how to use a lathe. And that's when I joined the club. And, obviously you got experience on how to use a gouge and sharpening and all that. So.
One more question. Anybody else? Go ahead. Yes.
Oh, thank
Great
you.
presentation.
Thank you. Thank you. I appreciate that.
You'll probably get a bonus.
I can only imagine.
Hey, oh,
I use the tool of choice that I use both outside and inside is a 5/8 inch bowl gouge with a 1/2 inch flute. I will, on an open segment bowl, then it really comes down to the types of wood. I will usually touch them up with a negative rake scraper, but if I'm doing something like tiger wood, I won't touch it with a scraper because the tear out is just too bad. Good question.
excellent.
Yeah.
Thanks
Thank
a
you.
lot, Tom. Tom put a lot of time into this presentation. I really appreciate that. So